Okay, so this is going to be a demonstration of what I'm calling the plumbing for a Kubernetes cluster predictive auto scaling function across physical compute. What we've set up here is a vSphere based environment where our Kubernetes cluster is running. I have one cluster for Kubernetes, and here we see the K8s master, K8s worker node 1 VM, and then on another host we have K8s worker node 2, which is currently powered off. So the only physical compute that we're giving to our K8s cluster is up in this prod manufacturing vSphere cluster. The use case will be ultimately a predictive function that will call a scaling function ahead of actual demand requirement. To do that, I've leveraged the REST API for both vSphere and Kubernetes, and using just get, put, or post through HTTPS, we will see that we can power on a VM running on another physical host and then submit a scale command to the Kubernetes master that will take a pod that's running right now only on worker node 1 and scale it to the powered on worker node 2, so that we're now running on two physical hosts. The scenario here would involve having potentially multiple departments, not just manufacturing but R&D, etc., that would be running with their own physical compute and their own clusters, and then leveraging a shared cluster in vSphere where when one or the other needed to scale out, they could take advantage of the additional compute that resides out here. This could be applied or extended further. This could go into the public cloud for a hybrid scenario. We could take it another step further and add in automation so that we're actually creating the Kubernetes worker node and then decommission it when we're done with it. That would be applicable, I think, more so to a public cloud environment where if you're bursting out into the public cloud, you don't want to have those resources sitting idle or even just powered off when you're not using them. So that might be that use case, but we're not going to go there here in this one. Simply, we're going to execute code that will power on this VM, and then the K8s master will wait for it to recognize that that is now ready, and then we'll submit a command to take a currently running deployment on worker node 1 where it's housed now and scale it out to also be working and running on worker node 2. So if we come over to our console, and I'm currently logged into this K8s master node, we can submit a command to get the current status of our nodes. And we see that worker node 1 is in a ready state, along with the master, of course. And that worker node 2, that's currently turned off here, is in the not ready state. The code that I'm using, I'll provide a link in the info for this video below to the corresponding post on berelevant.net, where you can look at that, and you can also read kind of the backstory that I've posted there in a couple of posts before this one in the series. Okay, so let's take a look at the deployment that we have. And we see right now I'm running this Nginx deployment. I have a running state of one pod, and it's on K8s worker node 1. So that's the one we have here. As I run the code, the Python script that's going to fire up the VM and then scale out, I'm going to have to wait a little bit while the master node recognizes that the K8s worker node 2 has come online. The default heartbeat settings for the K8s master to recognize that is a little bit slow for this use case, and it can be tuned with some parameters, but I'm going to leave it as is for now. I think in a production implementation, certainly we'd want to change some of those knobs a bit. Also keep an eye on this VM. As I fire off this line of code, you'll see this switch to an on state, and then also down in our recent task pane here, you'll see an entry come in. So everything that we do through the vSphere REST API, the operations are logged and tracked just as they were if you were in the native interface here. So I've called this scale out, and I'll execute it now, and we'll expect to see this K8s Win 2 come online. I've put in some statements to wait and tell us what's happening, and then at the end we should be able to verify that we've scaled out an additional pod onto an additional physical host. Okay, so we see that the VM has just come online. We see that that operation has been logged, and we're now waiting for the master to recognize the node, worker node 2 is being ready. Okay, recognize that the node is ready. It's performed the scale out operation. If we go ahead and look at our nodes again, we'll see that Kate's worker node 2 is now in a ready state. If we look at our pods, we can see that we've gone up to 2 pods now. We're still in the container creating stage for this pod that we just scaled out to worker node 2. If we issue the command again, we will eventually see that switch to running if all goes well. And there we have it. So what we just did there was we used a Python script or code base to implement RESTful API calls to both vSphere and Kubernetes and scale out a running service to additional physical compute in the vSphere environment. In a future post, I'm going to delve into the function that will be calling this, the predictive function. And if you follow along in the post on BeRelevant.net, you can get a sense for where that's heading. Thanks.